Hey everybody, this is Larry. This is me doing the bonus question. A little bit early, to be honest, on August 13th, 2022, before my daily prom. The reason is mostly just because of logistics, and today I do want to mix it up by still trying to do it one I haven't done before, but I want to do a difficult one that I haven't done before. Maybe there's still a lot. Oh, it seems like maybe that'll be okay. And also just want to give myself enough time because the contest is later today, so I don't want to start later, and then maybe once in the contest time I'm stressed, whatever. So I have time to rest a little bit, uh, because these things are exhausting for me. I'm old. Okay, hit the like button, hit the subscribe button, join me on Discord, and let's see if we could get a prom very quickly. Wow, that was very quick actually. As you know from watching my channel, there's a lot of the RNG is not always super fast, but today it is. Anyway, yeah, be sure to hit the like button, hit the subscribe button, join me on Discord, show me some love, and we'll see how these things go. And I haven't done these before, at least not on Leetcode, but hopefully we'll get through more of them now, one day at a time. Anyway, today's bonus problem is 903, valid permutation for DI sequence. You're given a string S of length n, where S of I is either D and I. A permutation is if it's a valid permutation if for all valid I. Okay, so it has to be okay. Well, okay. First is the mod song. Mod. I think one thing I've been really bad about is also just reading the problem. I think I skipped ahead a little bit and looked at the example. I don't know if you could see my eyes, but or at least in a way that track my eyes. But I was looking here, and maybe it's very easy to kind of I keep misreading stuff, so maybe I need to focus a little bit better. Though so D you have decreasing, I you have increasing, and number of valid permutations. The first thing to notice is that n is 200, so we can do some. In terms of complexity, we can do n squared or something like this, or maybe n cube if you have a very fast n cube, or at least n choose 3, which is n cube over 6. So something like that, right? At least in Python. The other, yeah, I mean, I think that's the thing I would notice. The other thing is that this is permutation. And I think, and I forgot to mention that the first thought that comes to my mind is going to be dynamic programming. Just because, valid permutation, it seems like a combinatorial thing. Maybe technically, I guess I'm not always sure, but, okay. So by default, one number, this is kind of, why is this only, okay. So I missed, so you're given the string, and you have n plus 1 string. Okay, I mean, they actually tell you that, but I think I just misread it a little bit. Let me actually write this as well down here for now. So the way that I think about these things is try to figure out how to, and because n is less than 200, we can just do some loop that's like maybe something like the suffix and then just count in a brute force way, or 200 or something like that. And then some formula based on that relationship, right? One thing that's kind of, the first observation that you need to make, and I don't know, I mean, this is an absolutely needed observation. I don't know if it's enough by itself, but the idea here is that, okay, let's say we brute force on the first number, right? Then here, I'm gonna copy and paste a little bit. Let's say we brute force on the first number. Here, technically, the way that we can do this permutation, let's say we remove the first number then, right? As thinking about suffix, then actually, on first number, then it'll be 0, 2, 1, right? 0, 2, 1 as well, actually. And then this will be 1, 2, 0, right? And what am I doing here is basically, well, this is just, yeah, these are just ones. Basically, what I'm saying is, you don't have to actually program this per se, but in my mind, that's just how you think about the recurrence or the transitionary state, is that basically after you pick a number, you re-index and then you have a suffix based on that, right? Okay. I think I have an n cube solution very quickly based off maybe I don't know, or at least that's my intuition from. And to be honest, I you know, when I'm just trying to talk out loud and trying to communicate my understanding of the problem as I'm seeing it. I'm solving these live, and this one for the first time, at least that I can remember. I don't have a good memory anymore. So I could be wrong on these things, but you know, these are live, so definitely, you know. But here, I'm, you know, already, and sometimes I may be wrong, but when I say these things, it's just from years and years of experience and solving thousands and tens of thousands of problems. So, you know, there's a built up subconscious almost understanding of some stuff, but sometimes they're wrong, right? It's just like a, you know, but that said, you know, that's what we're doing here. Okay. So for example, you could, let's say we could keep track of the last number, right? I think maybe that's it. But well, how do we structure this, right? Let's say we can brute force on one number, like basically with a for loop. Then how do you want to represent the rest of the state? Because it doesn't, it's not a, because it's not a, maybe, because it doesn't partition the sub problems. I think that's why I'm like, maybe that's not quite right. But what does the 3 mean to me? The 3 means that maybe that is good enough. You just kind of keep brute forcing it as n cube. Is n cube fast enough though? 200 cube is always a little bit sketch. We'll give it a spin. Right? So, okay, let's do it a little bit, and then we could do something like, say, I don't know, get count, number, naming is hard. And then we have the index, and then we just have the last number, right? And of course, we have to kind of be really careful. Is it the last number, or we have to be really careful because we also want to make sure that we index the numbers. I think another way to also think about it is that there's another dimension that's like x numbers left, so that when you re-index it, it just goes from n to n minus 1 and then n minus 2 dot dot dot. But also, and I kind of talk about this in another thing, or in the past, they're not independent of each other, right? So you could represent this x in terms of index. So I think in that case, that could be done. Like for example, left is equal to n minus index or something like this, right? Maybe minus 1, but maybe it's off by 1. But so like that's the highest number you can go, right? And then you just pick a number from it. I think that maybe that's fine. Or at least I think we have a correct algorithm. But as I said, and as I worried about, it is n cube, so it may be a little bit too slow. One other, but maybe that's good enough, because the other thing to notice is that n is less than 200, right? Meaning if n cube is too slow, all we have to do is run this locally, generate all the numbers, and oh wait, you can't because you have given an input. Sorry, I was thinking of another thing, but okay. I think one thing that I am going to do is just write it out and then see. You know, if it's too slow, we'll see if there's room for optimizations. But yeah. So okay. So if s of index is equal to d, then we have to be smaller than last, right? So then that means when next is less than last, it cannot be, you know. We have get count of index plus 1. What's it? I, right? Yeah. So, okay, and we have to do some basic things like total is equal to 0. Else we want it to be greater than last, so it starts at last plus 1 to left. Maybe inclusive? No, because we're doing 0 index, so and should be okay. So this may be off by 1, like I said, but that's fine. We're just kind of sketching it out for now. And then just return total. Right. I think this is correct-ish. So let's try. But I was trying to think about a better optimization, but yeah, I guess we have to actually do a follow-up on this. But the first number in range of n. Let's see. No, we want, well, it goes to the, because the index isn't the index of the array, but it's the index of s. So we have, you know. Also, I forgot a base case. Whoops. Yeah, I. Let's kind of give it a spin. I know I didn't memorize, but I just want to see if it at least gets it right for, well, something. Okay, that's not great. Let's see if I get it right for just this case. It is also possible that I'm off by 1 or something. Oh, this should be plus 1, because it should be inclusive. Because, wait, should it? It should be 0 and 1. Because it has n plus 1 numbers. Okay, yeah. Oops. Okay, so at least we fixed the D, but we didn't fix the DID. Okay. How do I fix the DID? I know that I usually go more explanation-y, but I'm still exploring right now, so we'll go over the dynamic programming part a little bit later, because this one is maybe kind of, you know, tricky. So, and I'm not super confident about it because this isn't as standard as whatever. If you are looking to learn about dynamic programming, try a easier problem first, and also check out my videos on those, because I usually do a better job explaining. But this one, I think maybe you're getting more of seeing my thought process and solving process versus like an explanation process. Maybe I'll do it later once I get there, but nonetheless, yeah. So, okay, I think this is this right, or am I off by 1? Is this right, or am I off by 1? Okay, that's too much. So that's not it. Okay, let's try an obvious case of DDD, and let's see if I could at least get 1. I should just like trace this. Okay, so that's right. And also maybe I, just in case that part of it is weird. Okay, I mean, I expect this to be wrong, otherwise, you know. Well, getting 0 is wrong in a weird way. What was my last one? Last one is ID, which is 0. I'm trying to think whether this gives me like an off by 1 in a weird way, as we do the indexing, right? So because now when you take away the I and you go smaller, all the numbers that were bigger should be okay. Huh. Okay, but actually got a lot of things wrong. What was like the last? Seems like my eye. So okay, so we did identify that the eyes are the issue. So okay, let's just. So maybe that loop is wrong. Yeah. I mean, hopefully it's just off and off by 1 or something, which is fine. Oh, maybe that's why. It wasn't that I have to do this, but this one, because after we do the reindexing, last doesn't exist anymore, so we don't have to do last plus 1. Okay. That makes sense. I was just being a little bit careless there. Let's run this. I know I still have a print statement as well. Okay. So this looks better. I don't know if this is fast enough, but okay. I mean, so now I'm confident, at least in the correctness, but whether this is fast enough is another story. So let's give it a submit. I know that I usually don't do cache on these videos, but yeah, okay. That's the thing, right? Is that on Leetcode specifically, 200 cube is 8 million, and that's not always fast enough. It always is depends on how they want to do it, right? For example, if you just give me, oh Jesus, I get so much spam phone calls, and now it shows up on my thing. I need to turn on like do not disturb. Sorry, friends, that was kind of scary actually. Focus mode. Need to set that a little bit. I don't know. I also maybe just need to set this not to be on my phone. Anyway, sorry friends. What I was gonna say is that because right now I'm just playing guess how Leetcode likes it, right? And that's a game that's like been very tricky lately, for me anyway. Because for example, you have 83 test cases. All right, let's kind of run something like, I don't know. Let's just do this. I think that should be fine. This is 6, so 12, 18. Just make it 20. This is 100, so 200, right? Let's run it real quick. See how fast this is. So this is 15 millisecond, which is not fast, not slow, right? But if you do like, I don't know, 200 test cases of these or something, maybe not even 200, right? Just like 30, right? 40, whatever, right? Then you would time out. And there's no way to kind of figure it out from just anything. And the distribution of how many test cases, depending on even there are test cases, because they don't do the timing based on one test case. They want the timing on all the test cases and combine the time. Yeah, but okay. That's why I wasn't super sure. Maybe if I did, I would have gotten this one a little bit faster. But the idea here, so cache, maybe is a good time to talk about this anyway. I do not. So if you're new to, dynamic programming and memoization, and if you are studying for interviews, do yourself a favor and don't use it. I mean, look, are you able to solve problems using cache? Yes. Can you explain why or how cache is implemented? Can you explain what's the complexity? And it may surprise you. Can you explain, all these other things about it, right? If I'm the interviewer and I saw this, that's what I would ask you about it, right? I'm gonna make it really annoying for you, to be honest. Because my thing is that like as an interviewer, the goal of interviewing is not to see if you got a problem correct, right? If I wanted that, we'll just give you an online assessment. Just here's a link, take a test, right? The idea, the point of having an interviewer is so that they, or in my case me, I can see how your problem solving skills are, how you think, and so forth, right? The first thing I would say to you, maybe, depending on how I feel, I suppose, if I see something like this, I mean, actually, I'm actually pretty liberal about these things. To be honest, I would just ask you like, hey, what's the complexity? How can you prove the complexity, etc. Right? But I would also just think some people might like if you like what if your interviewer doesn't know what it is, right? Because I actually know what this is, so maybe I would be like, hey, here are the questions. But if you get an interviewer who might not even know what this is, then you have to explain how it works. If at best, right? And you might not know. At worst, they'll just make you do it another way anyway, which is fine if you practice another way instead of just putting this everywhere, which a lot of people have been doing. So yeah. So and I know that today because I wanted to focus on understanding. Though it turned out easier than I expected. So because I think I thought that I had to do some n square thing, but that said, yeah. If you do want to watch like something that's more interviewee friendly, find another dynamic programming problem and check out my video on it. Because especially unless it's done for a contest, because that's my contest code. Contest code is different from my interview code and my production code, right? Makes sense. And in that case, then you'll see me explain it a little bit better. But in terms of complexity, let's think about this. So what can index be, right? Index can be from 0 to n. Fair enough. What's last? Last could also be from 0 to n. So yeah, and how do you find the time complexity? Well, time complexity is just equal to, roughly speaking, because sometimes there's amortization, but this time it's okay, which is just total number of inputs times time per input, right? This is like basically like, let's say how long does it take to get there is equal to total number of miles or kilometers for those of you in a country that uses reasonable SI units, times miles or hours, miles per hour, right? Wait, what? Maybe I did this example wrong, but anyway, hours per mile, right? And in this case, this would, you could do unit analysis and get rid of the miles to get the total hours, right? That's basically the same idea as here, is that the total number of inputs times the time per input is how you get this. And total number of inputs, and the idea behind memoization is that for every input, the output is exactly the same, right? So yeah, so if you give the same input every time, it'll always give you the same output. So you just save it down to use it for later, just like a cache outside of CS, I guess, but I don't know. Anyway, total number of inputs is just n squared, and each input takes O of n time, because that's the way that we did it. I think can you optimize this? Dun dun dun. I think so. I think there is a way to actually get it down, and that would be kind of cool. And the thing to notice there is that you're basically summing, like, I'll show you in a second, but I think there is a way to optimize this, and it's maybe pretty cool. But I could also be wrong, because that's part. So you're seeing Larry at his exploration state. So sometimes it's wrong, sometimes it's right. But yeah, we'll think about it. So total time is just all of n cubed, right? And space is same thing. Total number of inputs, but each input takes all of one space. So total space is all of n cubed squared. Okay, so that's pretty much all I have for this explanation. But one thing that I would think about is if you implement it bottoms up, for example, right? Well, if you implement it bottoms up, because the idea here, and I'm not gonna write real code-ish, or like as real as tight as I usually go, but basically you have something like, for each index, you might write something like, dp is equal to some two-dimensional array, times n or something like that, right? Something like that, and then you might have something like for index in range of n, and then for last in range of index for last is equal to n minus index, I think, because basically, yeah, something like that. I mean, this may be off by one. Like I said, this is meant to be more pseudocodey, and you should observe it at home if you're a few But the idea here is that now we have another loop of for I in range of last, or like based on if s of index is equal to d, dot 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 for now, dot dot dot, else for I in range from last to n or something, also dot dot dot, right? Well, and here the dot 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 is this thing, right? So we have total, we incremented by dp of index -1 of some I or something like that. I mean, I could, like I said, I'm doing a lot of hand wavy here just for teaching purposes, or like illustration purposes, right? So basically, if I were to but this is the optimization that I would be thinking about if I was this would be the optimization I would be thinking about if I was if the n cube solution timed out, then this is what I'd be thinking about. And I'm just trying to draw it out for you, so give me a second. Basically, for example, you could think about it as having like a lot of cells. This is bottoms up, but we could actually do this tops down as well. We'll see in a second. All right, dot dot dot, right? So basically, but the idea here is that maybe I need a standard grid to paste onto here, so I don't have to draw this every time. But basically, let's say you're here, and depending on whether you get a D or an I, you basically sum all of here or all of here, right? Something like that, roughly speaking. So what does that remind you of? For me, what that reminds me of is prefix sum, right? So here, this input takes O of n time because this input takes O of n time because of this loop, right? And of course, it's not O of n; it's a little bit faster than that. But the big O is O of n, right? But if we could reduce this to O of 1 using prefix sum, then it becomes much, then it becomes O of 1, and then this total time becomes n squared. Let me see if I can upsolve this now, since I do have more time. So that's one benefit of doing this early, is by doing it that way, right? And sometimes for me, it's hard to visualize these things until I type the code out a little bit. Use whatever you need for visualization. You are, how you make these process. You are the sum of your experiences. With practice, you're able to do it better. But once I wrote this out, I could see, I just, do all these things, right? So here, maybe the way that I can write is, get sum of count, given some index, from, okay, so this is I, right? Something like that. Basically, I'm trying to, here. And also we want to cache this as well. But here, the way that you think about it is that if I is equal to 0, do we return 1? No, we return get count of index on I. Else, I guess we don't have anything else, but we do get count of index of I plus get sum of count of index I minus 1, right? So this is just prefix sum recursion. Again, I'm not going to go over the use of cache in this one because we're going over advanced topics. Ideally, you already know how to do this. You could write this also a little bit differently, but that's the same general idea, right? And then here, in this case, then now, and we maybe should have mod this as well. Fine. But, and then now, in this case, instead of writing this, we have total plus get count, or get sum count from index plus 1 I, right? And then mod, I guess. But I mean, you're only doing one, so it should already be modded. But just for reading's sake, right? So now we reduce this to O of 1, and you can kind of prove why this is O of 1. Amortized O of 1 because now we're skipping the for loop, right? And also some stuff about prefix and reusing substates. But yeah, and now we reduce this to n squared. Of course, you want to do the same to here before. I mean, okay. So we didn't reduce it to n squared yet because we have to do it here. And here, if you have experience with prefix sum, you're probably already ahead of what I'm about to say. If you haven't, then the idea is just we get the sum of count plus 1. We get it to left. And again, maybe this is off by 1, but that's going to be the general idea. Left minus 1 because we want to do it inclusive, minus get sum of count of index plus 1. We count from last, so we want to subtract from last minus 1. Unless last is 0. Yeah. Okay, so if I is less than 0, then we return 0. Just to make it easier. So I think this is roughly correct. Maybe I'm off by something here. But now this is how we get it to okay, well, mistakes were made. How am I off by so much? Maybe I subtract this one. Okay. Well, no, I'm just doing the DDD, right? Did I miss this one? Dun, dun, dun. Let me double check. Alright, let's start with something more basic. The idea should be right, or maybe not. Maybe I'm making a fool of myself, but we'll see. How does 35 even come up? Or D is 3. Oh, is it because I did it this way? Oh no. Let's see. Well, let me think about this for a second. So I'm surprised that this actually gets it 1 for D, but okay, so it goes, okay, 0, 1. Okay, maybe just print it out. Well, that's the idea that I would have. Maybe my implementation's a little bit off. Clearly, it's definitely not very right. But from 0, 0 is 1, and then 0, 1 is 3. So it's not giving me 0 for an impossible case. So it's overcounting something. So for 0, 0, this should be 0, and this should be 1. So it's adding 1 to some stuff. Why is that? Okay, so if this is 0, oh, why do I have I here? That's at least something. It should be last. And what was the old loop? That was just a bad typo, I think. But is it I'm trying to think where it is now. Minus 1. Yeah, I think this is minus 1. Okay. I mean, it's easy to get these right, but at least, but it's embarrassing to get those wrong. So, well, that's just a typo, though. Okay, cool. Wow. Yeah, so before it took like I didn't see the timing, but before when we had the n cube algorithm, it took 300 milliseconds. So now you could see that we reduced it to n square. Let's see how fast that runs. Cool. Wow. I mean, I'm pretty happy about this. I mean, I think this is probably as fast as you can get it, at least with this style. But I'm happy that we reduced n cubed to n square. I think this is also one of those things that Leetcode is kind of dubious about, because I feel like if this was in a contest today, maybe this is just my commentary. If this was in a contest today, like I feel like NQ might not be fast enough in Python, but it may be fast enough in Java or something, right? And n square is a little bit too slow, or too like you have to do n square in Python, but not in other languages. Well. I would also say that if, and I get this comments from time to time about this percentile thing, I wouldn't worry about it, to be honest. In general, especially in this case, we use something like cache and we're doing it top down instead of bottoms up. That's going to be slower just from that, but I wouldn't worry that much about it. Cool. That's pretty much all I have. I think I explained this pretty okay. This is obviously live and a little bit tricky, but especially if you have to make this optimization, but hopefully this is somewhat new and instructive in terms of finding this new hotness, because this is something that I on my skill level, whether however you want to think about it, it's not an optimization I make a lot. So yeah, but this is the progression on how you would think about it. So cool. Yeah. That's all I have for the bonus question. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Let me know in the comments if you like these bonus questions. Bye bye.